Welcome back, everybody. Like I promised, today we're going to be putting the cylinder heads on our 383 stroker engine and finishing this thing up. The heads that we have chosen are made by a company called RHS, Racing Head Service. These cylinder heads have, well, we did a valve job on it. We cut the seats and so forth ourselves because we like to make sure that we want to know what's going on in here. We want to make sure that we get the multiple angle, the 3-angle valve job. We want to know that the seating is correct and everything like that. The chambers on these heads are 64 cc's. Now when we say the chambers are 64 cc's, what they mean by that is if you were to fill this chamber, what we do is we put the spark plug in, we put a plexiglass plate over this, and we fill this chamber with liquid. However many cc's of liquid the chamber holds, that is how many cc's our head is. This is important because the size of this chamber is a factor in compression ratio. So we have a set of 64 cc chamber heads, and we also have another thing you'll hear when they talk about cylinder heads is they'll give you the cc's of the runner side. So when I say this head has a 210 cc intake runner, that means that if I were to lay this head up on its side and fill this port up with the valve in, of course, with liquid, it would hold 210 cc's of liquid in here. That's quite a bit bigger than a stock head. The stock Chevrolet heads are usually around 155 to 165 cc's. With a street performance engine, 383, 400, you're going to need a much better head if you want to make any power. So the cc's of this head are going to give us the ability to flow a lot more air than we normally would have. We went ahead and set up our valve springs for our roller cam that we put in here. So the valve springs came with our roller cam kit. So the heads have had a complete valve job. We set the springs up and got the heights correct and everything, and they're ready to go on the head. So the next step, I guess, is to put them on. So you want to get a good quality head gasket. We chose the Felpro, and the Felpro gaskets are some of the best out there. This particular one is about 42 thousandths thick compressed, which is perfect for what we want to do here, compression ratio. There's a couple of dowel pins on the deck of the block, front and back, and this head gasket just locates on the dowel pins, just like so. Now, you should not be using any kind of sealer on Felpro head gaskets. Some guys like to copper coat these, and that works okay, I suppose. But Felpro tells you that it's really not necessary. You don't really need any of that on there. Go ahead and wipe your cylinders out real good with a clean rag. Make sure everything is nice and clean in there. And at that point, we're ready to set our head on. So as far as the cylinder heads go, I will take and put a couple of bolts in the heads. Shift over to the cylinder head here and I'll show you what I'm talking about. I will take a couple of the head bolts. Now we bought a new head bolt set for these because, well, we just wanted new head bolts in here. So we got a new Engine Pro head bolt set, and I will take and just put a couple of these head bolts in and use them as guides. And also, when you put head bolts in, you also want to make sure that you lube them. Use some type of a heavy lube. I like this stuff here. You can use light motor oil too. Now these bolts already have Teflon or sealer on them, rather. The thing about small block Chevys is you have to seal the threads here. You either have to buy a set of bolts that are already sealed, or you have to seal those threads, because the bolt holes in the small block Chevy go down into the water jacket area, and coolant will seep up these threads and leak into your oil if you don't have some type of sealer on the bolts. Okay, so now our cylinder heads. The cylinder heads have been rebuilt and prepped, and they're ready to go. Fresh valve job. We didn't actually mill this set of heads because the surface was perfectly flat, and we wanted to kind of keep our compression ratio at a level that was manageable for pumped gas. Okay, so what I will do is I'll take these two head bolts, just put one in the end there and one in the end there. And now I'm going to use those head bolts as guides. So let's go back over to our engine here. We take a look at our engine that's set up and ready for this cylinder head. Now I'm going to take, and I'll move this over a little so you can kind of get an idea of what I'm doing here. Then I'll just take my cylinder head, and we want to lay it straight down on there. The best way to grab a cylinder head when you put it on is like I've got this one here. I'm grabbing right here at where the lifter valley, the center of the head, and in the two exhaust ports. That way you can you look straight down at your bolt holes and you can go right in with them. You don't have to worry about fighting this thing. The bolt holes kind of act as guides, so you can get this thing on there. And it should go right down on your pins. You have a couple of pins down there, the head drops down on, and you're good to go. Now that you've got the heads on, you notice we put all our bolts in. Another thing we did off camera is we went ahead and installed our lifters and the lifter bores, and you can see we got quite a bit of oil in here. You want to coat these with oil and make sure the rollers have a good amount of oil on before you put them in. I didn't bother doing that on camera because it's pretty simple. I mean, it's a matter of just sticking them in there. So now we want to torque our heads, and it's best to use a three-step process, and there is a torque procedure on the heads. Most of you are aware of this. The torque on the small block Chevrolet cylinder heads is 70 psi. Now I've already gone through two steps. I did 35, 50, and now I'm going to do 70. This is the final torque. There is a torque sequence. The torque sequence basically starts in the middle here, and it works its way to the outside in a circular pattern. If you're not sure what that torque sequence is, you can look in the manual, in the service manual, and it will give you the torque sequence. So we're gonna torque these up in sequence because we don't want to have any kind of warpage on the heads or distortion on the head or head gasket problems. So I'm going to continue to torque these up, and then we'll move on. Next thing we want to do is put our rocker arms and our push rods. We got our rocker nuts and everything in here. We decided not to go with a roller rocker on this engine because of budget constraints, and also because it's a mild enough engine that it's really not going to turn the RPMs where roller rockers are going to come into play. So we got our push rods in. We've got the right length. We went ahead and went with a hardened push rod. Push rod length is important. You got to make sure that is right, so your rocker arm geometry is correct. We went with a push rod that is 150 thousandths longer. The reason being is the valves that we used on this head are 100 thousandths longer in length than the normal valve, so the push rod also has to be 100 thousandths longer. Plus we have a small base circle cam, so because the lifter actually sits a little lower in here because of the smaller base on the cam, we ended up needing about another 50 thousandths. So we have a roller type hardened chrome moly steel push rod that is 150 thousandths longer than the standard length roller push rod. So once you get your rockers on here, now these rockers are still loose, they're not adjusted yet. I'm going to walk you through the adjustment process. Now the roller camshafts are a little different. When I say they're different, what I mean is, especially a big roller like we have in this one, the base circle on the bottom of the cam is usually pretty small, and so what we have to do is we have to use a different valve adjustment. I have another video, small block Chevy valve adjustment, that you can watch, and it has a milder flat tappet cam in it. As far as these bigger duration rollers go, like we have in this engine, you have to use a different procedure because of that small base circle. It's hard sometimes to find the exact base circle. They might have a bigger ramp leading up to the lobe. In fact, most of them do on the rollers, especially the small base circle cams. And so what we have to do is there's another procedure that we have to use instead of just doing the firing order, and I'll show you that. So right now, both of those lifters are down, they're off of their load. So I want to rotate this. This is my exhaust valve. I'm going to rotate that exhaust valve, and you'll see this start to move here. Now you see how that exhaust just started to open? Right where that exhaust just starts to open, now you can adjust your intake. That way I make sure that I'm on my base circle. So my exhaust just started to open, now I'm going to adjust my intake. When you adjust it, what we have here, these are hydraulic lifters, so you have lash. You can see that push rod is kind of flopping around between the lifter and the rocker. So what you want to do is you want to run that down until you get rid of that lash. So you just kind of take the push rod and you move it up and down and you just kind of, you'll feel that lash or that clearance disappear as you run the nut down. So I run the nut down until I just pinch the push rod between the rocker and the lifter, and if you see I'm trying to pull up and down on that, I can't move it. It's pinched in there. The rocker's still a little bit, you know, it has a little bit of play in it, but I don't have any up and down movement. A lot of guys will tell you, well, what you need to do is lock this down till you can spin the push rod. Don't do that, because right now this is at 0 lash and I can spin this push rod real easy. If you go down to where the push rod is tight enough that you can't spin it, your lifter is going to be too tight. You don't want that. So now that I've got this at the place where I have 0 lash, then we're just going to go another 1/2 of a turn, and that is now adjusted. And I can go through the firing order now, and I can do all the intakes. I can go to the next piston in the firing order, which is number 8, and I can go through the entire firing order, 1, 8, 4, 3, 6, 5, 7, 2, and I can watch the exhaust valve. When the exhaust valve just starts to open on every cylinder I go to, then I adjust the intake. Okay, so we've got all the intakes adjusted. Now the next step is to do your exhaust. What we're going to do on the exhaust is we're going to rotate the engine and we're going to open the intake valve all the way. So this is our intake valve here, and these are adjusted, the exhausts are not. So we're going to open our intake valve all the way. So you'll see this lifter, this intake rise here. We'll rotate this, and there's our exhaust. We want to watch our intake here. So this is our intake valve. So we're going to let it open all the way to its max lift point. And you can put a dial indicator on here if you want, or you can just watch it. So my lifter is at maximum lift, or it's all the way up now. And I'm going to keep going, and you're going to see this start to fall. It's going to go down the other side of the profile on the cam. So I'm coming up here, and there it goes. It's moving down. When this lifter just starts to close, when my intake just starts to close, your exhaust is on your base circle. Okay? So open the intake all the way, and when it just starts to close, that's where you want to adjust your exhaust. Okay? So we got lash here. We got this lash on the exhaust. You can see it. So we're going to go through, and I'm going to run this down till I get rid of this lash here, this clearance. Still got a little bit there. There. Now I have no lash. I have no up and down movement here. And I can actually, you know, still move the rocker a little bit. At that point, then just go a 1/2 a turn, and your exhaust is adjusted. So now the intake and exhaust are both adjusted here. Now you can do the same thing. You can go through the firing order. If you turn the crankshaft 90 degrees, or about 90 degrees, the next cylinder in the firing order, which is number 8 back here, you will see the intake start to close. And you can go through the whole firing order and adjust all of your exhaust that way. Just repeat that 8 times and you got it. Once you get the valve train installed, now we got to start thinking about buttoning up the lower end of this engine. We've got our oil pump here, and we have Chevrolet has a press-in pickup tube, and these are they push in here, and you can kind of move this thing around. Well, I want to put this at a pronounced angle here, and the reason I want to do that is because the pickup screen here, the bottom of the pickup screen, it needs to be approximately a 1/2 inch off the bottom of the pan. So I don't have my oil pump torqued on here. I just put it on and stuck the bolt in. And what I'm going to do is I'm going to put this up at a pronounced angle. I'm going to pull this pickup screen up higher than it needs to be, and then I'm going to put my pan on and let the pan push this down so that I know where the bottom of the pan is. And then at this point we're going to take our oil pan, and your oil pan needs to be really clean before you do this. Make sure it's cleaned up. Take some extra time on it. Then we're just going to take our pan and we're going to set it straight down on here on the bolts, and we're going to let the pan, I know that pickup screen is up too high, so we're going to let the pan push that pickup screen down. We're just going to push this thing down, okay, until the pan is flush on the pan rails here. Once it's flush on this pan rail on both sides, make sure the pan's on there, then just pull your pan back off. And what we have here is we actually have taken and we have pushed our pickup screen down to where it's actually just touching the bottom of the pan. So what you want to do at that point, you can take a ruler if you want to. You want this thing to just be about a 1/2 inch above the bottom of the pan. So I'm just going to take and I'm going to move this just about a 1/2 inch right there. That's where I want it. Now another thing is, it's a really good idea to either have this welded, have this pickup screen welded, or weld it yourself. There are a lot of ways you can do this. What I like to do, I just take a little, now this is just a piece of a oil pan rail bracket that I chop these up and use them. I don't really like to weld to, some guys will weld the pickup screen on right here, and they will weld right into the cast iron body of the pump. I don't like to do that because I don't really like to weld to this cast iron pump. The weld doesn't really hold that well, and when you're welding steel to cast iron, it's just not the optimal situation. So what I've discovered is that if I just take this little 10mm bolt out here, this is takes a 10mm socket, and that's one of the bolts that actually holds the pump housing in. And then we just take and set that bolt aside, and I can take this piece of bracket here and I can actually bolt it onto the pump, and this runs over, and I have a place now where I can tack weld this onto the pump pickup screen and hold it in place. Before you do that, it's a good idea to take a marker, because we have this pickup screen positioned at the height we want it now. So it's a good idea to take a marker and just mark your pump. You can use a metal marker or a permanent marker. Mark your pump right here, and also mark your pickup screen. Make sure that, because when you put this bracket on here and start bending it and so forth, this pickup screen might move. So we want to make sure that we know if this moves, we can put it back, adjust it back to where it needs to be before we actually weld it. So we're going to take our bolt. Now I have a slightly longer bolt that I put in here. You can go to a hardware store and get one, and I get a longer bolt, and it's about that much longer. Hopefully that makes sense. That way we have a good fit in that pump. So I'm going to run the bolt down, and I'm just going to put this bolt back in with this bracket on here and snug it up. We want to get this in here and get it tight. So now I'm going to locate this bracket right about there, and we run this down, and you can torque this on if you need to. I just snug it up so I know it's about as tight as these other bolts. Now I have my bracket here over here, and what I'm going to do is I'm probably going to heat this and just bend it around here a little bit and cut it off, and that way I have a good amount of bracketry here to weld this with. Then once it's heated, of course I took the end off of that, and you can just very carefully, you don't got to get crazy with it, but you can use some vice grips to kind of kind of contour this around your pickup screen, and it makes a really nice nice bracket. Just be careful, you don't want to damage the pickup screen or anything like that. As long as you're careful here and you don't get too crazy with it, it'll be fine. And again, it doesn't have to fit perfectly around the pickup screen. We just have to have a few spots here where we can, we can go ahead and take our MIG welder and tack it. And then again, when we tack this down, what we're doing is we are tack welding this bracket to a steel pickup screen. That way we don't go into the cast iron. So we got that heated up and bent around there. We got that tight, and our mark didn't even move. So we're right where we need to be. And watch out, because it's a little warm. The pickup screen does get a little warm. It's not overheated, but it's a little warm to the touch. So now we can go over to our welder. Theoretically, we could just leave that like that, and this would actually help to hold the pickup screen in there, but we're going to put a few tack welds on it just to make sure. Okay, so if you take a look at this, folks, we got our bracket on there, and I've got gloves on because it is a little warm. I just tack welded this, but you can see we put a couple tack welds here, and that's going to assure that this pickup screen is not going to come out of here. They are a press fit, and but keep in mind that Melling, who makes this pump, they actually recommend that you tack weld the pump on here somehow. So you put that little handy dandy bracket on there, you tack weld it, and you're in business. And our mark is right where it needs to be, so our pump level, we made sure that this didn't move, and we're ready to go. Next step is going to be installing the pump on the engine, and there's a couple of things we need to talk about as far as that goes. So at this point, you're pretty much ready to install your pump onto the engine. Another tip I would give you here is, as far as the bolt length goes, we've got our retaining bolt that goes into the pump here. The depth of the hole on some of the rear caps on the Chevy blocks can vary. So what you want to do is you want to measure, I'm using dial calipers here, the depth gauge. You want to measure the depth of that hole there. And we want our calipers to be about even with the mating surface here of the pump. So I'm just going to eyeball that and bring my calipers up till I'm just about even, and that's the depth of my hole. You want to make sure that the bolt isn't deeper than the depth of the hole. And this one we got lots of room. You can see that there. We got lots of room. So if this bolt were too long, it would actually bottom out, and you would be turning it or torquing it into the rear main bearing, because the back of the rear main bearing, this is an open hole down here, the back of the rear main bearing is at the bottom of that hole. So you just want to make sure that your bolt is not too deep. The other thing is, when it comes to the oil pump drive shaft, don't use that cheapy plastic thing that comes in the gasket set with the factory drive shaft. Those are junk, especially anything that's going to be in a high performance situation. Your best bet is to get, this is an all steel. It has a sleeve up here that's steel, and of course it's ARP, so I don't really need to say any more than that. You want to go with a good quality intermediate shaft when you put this thing on. You don't want to use that plastic cheapy thing. So we're going to open this up, and then we'll go ahead and install our pump. This drive shaft here, it has an end on it, and it just goes on to the pump here, just like the other shaft would. And then you just set this in here. It's okay if this oil pump drive shaft flops around a little bit once you get this on there. If I set this down, you can see that this thing is kind of moving around. That's normal. Don't worry about that. You just set your pump on there, and you want to take and you want to torque this bolt to 50 pounds. You don't want to over torque the bolt here on this pump, and the reason being is that those threads back here are going into, the threads are in the rear cap, in the rear main cap of the engine. The torque on these bolts is 50 pounds, so you want to make sure that you don't over torque that, because you could pull the threads out of that cap, and then you got a real problem. So we're going to set our torque wrench for 50 psi here, and we're just going to go and we're just going to torque this bolt to 50, just like that. And that's it. Your oil pump is installed. Another thing I would suggest is before you actually put the pan on this engine, that you go through and you re-torque, check all your torques on your bolts. I've already done that. I did it off camera. But just as a precaution, go back through and make sure that all your rod bolts and your main bolts are torqued, and that way you don't have any problems. The next thing we need to do is put our timing chain cover on. With a roller cam, there's a couple of extra things that you got to do. What we have here is what we call a thrust button, and the thrust button, this is going to locate against the front of the cam here, and this other portion here is basically going to sit up against the front cover. So what this does, because the roller cam has to be held in the block and have a little bit of end thrust, this is a little spring-loaded, what they call a thrust button here. So it sits in here and it gives the cam a little bit of cushion. However, these thrust buttons most of the time are too thick here, and they're made so you can shave or machine this pad to get the right thrust out of it. So there's a little bit of a procedure that you have to go through to make sure, and you can see obviously this thrust button is too long here. But of course it goes and sits inside the cam. So there's a procedure for that. The way that I do it is I'm going to take a ruler or a straight edge and I'm going to lay it right across here. But before we do that, I will also take my gasket that I'm going to use, and I'm just going to set that gasket on here because we want to be as close to the right measurement as we possibly can get. So I just lay my gasket on there, and then I'm going to put my straight edge right on top of that right there. And we'll take our dial calipers here. We have a set of dial calipers, and we have a depth gauge set on this. So I'll just take my dial calipers and we're going to measure the depth. We want to know how far this is. So we're measuring from this surface here to the depth. Now we do have the thickness of the ruler here, because I'm going from the top of the ruler to the inside of that cover. So we have to subtract the thickness of this ruler here, if that makes sense. So let's lock this in place. And we have 847 thousandths approximately. 847 thousandths. So what we're going to do is now we're going to take and measure the ruler, because I went from the top of the ruler to the surface of this, and we actually want to subtract the thickness of this ruler from that. Puts us right at 770 thousandths. So what I want is I want that to protrude 770 thousandths out of there. And I'll show you how we do that. So I've got two bolts in here, and here, and I've set them both for exactly 770 thousandths. Then we're going to take our straight edge, and we're just going to go across here with our straight edge, because that's where we want to be. So I just put this here across the straight edge here, and we got a little clearance between the chain and the straight edge. So then at that point we can put our thrust button in there and see where we're at. So the thrust button is just going to, and again I've got the bolts out of this, but it's locked in place. So we're just going to slide our thrust button in, and then we're going to put our straight edge up against the thrust button. Okay, so we got a lot of extra clearance here. Hopefully you can see that. This thing is too thick. We're going to have to take and machine down one side of that thrust button, because we need this thrust button, the distance of this button needs to be flush with this straight edge, and you can see we got a lot there. So I'm going to shave this off and we'll try it again. Okay, so If you take a look at this, you can see that it's been shaved down considerably. Off camera we took and shaved. Now if you don't have the capability to shave this thrust button correctly, we have a surface grinder we use to do it with. I wouldn't do it with a bench grinder. I'd have a machine shop do it if you don't have that equipment. But if you'll notice, once we stick this in and we know that our bolts are where we need to be, if we put our straight edge up here, now we can see that we have a little bit of clearance. This is about a 4/1000 feeler gauge here, and we're able to get it in there just snug. So we got about the right amount of clearance. That's just what we want there. So once you get to that point, then you can go ahead and put your bolts in. What I like to do on the cam bolts, just as extra insurance, of course it's optional, but I will take just a little bit of Loctite, and of course we're going to torque the bolts, but I just put a little bit of thread locker on these, because if your cam bolts come loose, you're basically going to toast your motor. So we don't really want to do that, especially after all this time and effort. So just put a little dab of Loctite. You don't have to put a large amount. A little bit of thread locker on there. Get your bolts in, and then we're going to torque them to specs. And that's basically it. I mean, we're ready to put our front timing chain cover on. We know it's clearance correctly, and so we'll put our front seal on and put our cover on once we get these torqued. And not a bad idea to use some grade 8 bolts here as opposed to the stock ones, some upgraded bolts. And the shoulder of the bolt goes in and actually kind of helps to hold that thing in there. And once the cover's on, the cover's going to sit up here, and it'll be fine. It's designed to sit in there just like that. Okay, so we got our gasket on there for the timing chain cover. We got our timing chain cover here. We're going to paint this, of course, and we have our new seal installed. One of the things on the seal is you want to make sure that you lubricate this seal. Okay, so we've got our timing chain cover on with our timing tab. We got the bolts all torqued. One of the things you want to do before you put the oil pan on is you want to take some assembly lube and you want to oil the pins here. These wrist pins, you want to take, before you put this pan on, and put some assembly lube right on every one of those wrist pins there. And you'll probably have to rotate the motor to get them all, but you definitely want to make sure that you have the pins are nice and lubed. This is one thing, just a little extra insurance. We had oil on them when we put them together anyway, but make sure that you oil up all of the pins before the pan goes on. As far as the oil pan goes, in your gasket set, in most sets you'll notice that you have 2 gaskets for the front of the pan. This is the front of our pan here. There's a thin gasket, and then there's one that's considerably thicker. You can see the difference there. Well, to figure out which one you need, you actually have to measure from the pan rail to the center of that there. Felpro does a really good job of explaining that. If you take a look at this, they show you what your measurement should be here and which gasket to use. So if we measure from the pan rail to the center of that and we get 2 1/4, we need to use our thin gasket. If we measure from the center of that and it's 2 3/8, we need to use our thicker gasket in there. So I'll show you how to do that. It's real simple. You can use a ruler or a set of dial calipers. I like the calipers. So what I do is I'm just going to take a straight edge or something. I'm just going to lay it right across here. Now we have an inside gauge here on our calipers that's going to give us a reading. So I'm just going to go right to the center of this, and I'm going to run this up until I just touch the bottom of this ruler that's sitting on my pan rail. So I'm going to go up and I want to measure that distance in there. Okay. So I look at this, 2 inch, 380 thousandths. So that's 375 is 3/8. So it's 2 3/8. So according to our paperwork that Felpro gave us, we need the thicker of the 2 gaskets to go on the engine. You need to make sure you do this, because if you need the thicker gasket and you put the thin one on, this thing is going to leak like a sieve when you get it in the car and start running it. If it's the other way around, you need the thin gasket and you put the thick one in there, it probably won't leak, but you're really going to be like probably tweaking your pan and having to pull it in with the bolts and it might distort the pan and so forth. So you want to make sure you get the right gasket in there. So you also have a rear gasket, which is this one here. It's got the little end on it to receive the end of the gasket. So that's going to go in the back. I like to take and put, I don't like to use a lot of silicone on the pan, so I don't want to get any into the lubrication system, but I'll take a blob of this and put it in each corner, front and back, and then I'll just kind of lay my thicker gasket on there. And the same thing in the back here. I'll put a blob of silicone in each corner, right down in there, and then this thing just slides in there like that. Okay. Now the end of the gasket, which is that piece right there, is going to go right in here, and we have studs in here, so you got to get this in there and get it over the stud, like so. Same thing here, this is going to go over the stud and underneath this thick piece here. So we'll get those in where they go. Put this one on the stud and put it underneath our gasket. Once you get to that point, just push this thick gasket down on top of those two pieces. And I'll also put just a little blob of silicone in each corner, because this is where they have a tendency to leak. So we want to make sure we don't have any leaks here. Right where these gaskets meet, let's put a little bit of silicone here. A little bit of sealer. Now at that point, we got everything torqued, we got our pump on and torqued, we got everything set at the height that needs to be, our pump's welded on. Basically we're ready to lay our pan on here. So then at that point, take your pan that has been thoroughly cleaned, of course, and I always like to take and give the pan a shake like this and make sure there's nothing rattling around in there, because if there's anything under this baffle, a washer or something, that could cause you a real problem. So make sure you shake this pan really well. Make sure you don't got anything in there. It's just a little safety precaution that I like to take, because you never know. So we want to line these gaskets up as good as we can, and then we'll go ahead and we just lay our pan straight down on, get our bolts in, torque everything up, and we're in business. And that pretty much buttons up the lower end of the engine. So we've got our pan and our covers on, and we've put our initial paint coat on this thing. Now we have to put our balancer on. This is our harmonic dampener, our harmonic balancer. You never want to take a hammer and beat this on or anything like that. You have to get an installation tool. This is a kit that you can rent at AutoZone or buy anywhere. We chose to buy it. It's got a piece for the crankshaft that goes in here. You just screw this into the end of the crank. And this doesn't need to be real tight. You just hand tight. And then this piece here is going to go through and grab that. So we're going to put this on, and we're just going to screw our inner bolt into that piece there until it's flush. And you want to kind of leave this loose in the crank because you want to be able to get it out of there. Then you've got this bearing and this nut. Well, you want to lubricate this. You want to make sure this doesn't go on dry or anything like that. So put a little bit of assembly lube or oil or something on the end of that shaft. A little on the keyway there. Now, when you slide the balancer on there, be careful not to damage these threads here. We're just going to real carefully put this over and find our keyway here, and it'll slide onto that key. Then you put your bearing on and you run the nut up. My advice to you is to get a wrench and hold this piece here so that end piece doesn't get tight in the crankshaft. If it does, you might have a hard time getting it out once you get the balancer on. So we're just going to run this up here. Take a crescent wrench, and then you get another wrench for this one here. Just grab a couple of crescent wrenches here, and I'll put a crescent wrench on the big nut here, and then I also like to hold this here. It's a good idea to hold this. That way that piece that's screwed into the crank doesn't get too tight. And just hang on to this one here, and then you can just go ahead, and this tool does a real nice job of pressing that balancer on. Once you get it up there, you'll feel it stop solid. Okay. That thing is stopped right there. That means it's bottomed out in there. Once it stops solid, don't keep going, because you'll snap this tool off. At that point, just back the nut off, and it's pretty simple just to take this whole thing out of here. And since we held this with the wrench, that smaller piece in the crank should be fairly easy to get out of there. The last thing you want to do is get that stuck in the crank. Believe me, I've done it. It's no fun. See how it's nice and loose? So we have no issues getting that out. And that's it. Your balancer is installed. Now, as far as the intake goes, we've got our intake gaskets on here. Keep in mind that these are performance gaskets that are needed for this head. It has a larger port than stock here. The Felpro 1207 is what we chose. What happens if you try to put the stock gaskets on here is that the portholes here are smaller, and the gasket is going to block off a portion of this port. You don't want to do that. I always like to put a little silicone under the four corners, and then I take some bolts and just lightly hold the gaskets on. I let the silicone set up, and then once those have set up and are in place, then we can go through the procedure of installing our intake manifold. The intake manifold gaskets come with these two little end gaskets here, and that's for the front and the back of the engine. The best thing you can do with these gaskets is toss them in the trash, because they're worthless. What you want to do is you want to put a bead of silicone along here, because if the heads of the block have been milled, which we did mill this block, it actually changes the height of the block here, and it can change how the manifold sits here. If you don't mill the block here, which most people don't, and we didn't, then it's going to change the height here, and that gasket on the end could actually hold the intake manifold up off of these gaskets. So what you want to do is you want to take your silicone gasket sealer, and you want to put a nice, generous, thick bead across the front and the back. The other thing is, those factory gaskets that go on the end of the manifolds here, they always leak. Every GM small block Chevrolet from the factory ends up leaking out the front and the back of the manifold. If you put a thick bead of silicone front and back, you'll never have any leaks. It makes a nice solid barrier. The manifold sits correctly, and you don't have a leaking problem. So it's always best just to do it this way. I've been doing it this way for many, many years, and I've never had one of these leak on me. So we got a nice generous bead. We put silicone on all the water jackets here. Now our intake is ready to go on the motor. This is our intake manifold and Proform carburetor. Now this intake was sitting around for quite a while, but we had it wrapped up in plastic, so it should be okay. What you want to do is you want to take your intake, make sure the surfaces are clean. We've got these cleaned off. Take your intake, look at your bolt holes, and you want to set it straight down on there. right down on that silicone. Once you get straight down on, it looks good, the holes are lined up, and you can start putting your bolts in. Now, on aluminum intakes especially, you want to make sure that you use flat washers on this thing. You don't ever want to just put a bolt in here, you want flat washers here. So we're going to get our bolts in with our flat washers and torque them in sequence to specs. Alright, so next we're going to talk about how to install a distributor. I use the word drop, but we're really installing it. This is our billet distributor that we've got for this engine, and we're going to put this thing in. So you see we got our intake manifold on and torque. We got our valve covers are just sitting on here. So the first thing you want to do, we'll just take this and set it aside back here because we haven't put them on yet. The first thing that you want to do is you want to get the engine to top dead center compression stroke on number 1. This is number 1. And the way you can do that is you rotate the engine and watch your intake valve here. So we've got some studs in here that are going to allow us to rotate this engine. So we're going to rotate this around until our number 1 cylinder here opens, or our number 1 valve here opens. So and we're probably already pretty close to where we need to be. There's the exhaust closing. Okay, so there's our intake. Our intake valve is opening right there. So we're gonna keep going. We're gonna open that valve up, and then we're gonna let it close. So we're gonna come up. That valve is closing. Now after this valve closes, we just bring our 0 mark around to 0 on our tab here, and you'll hear the compression. I'll put my finger over this hole and you can hear that compression. So we want to come up to 0 here, and that's going to put us at top dead center on the compression stroke. So top dead center right there is our 0. We're right here, we're zeroed out. So right now we're at top dead center compression on number 1. Okay, and so now that we have got that located correctly, we can take our distributor and we can install it in the engine. So we come around to the back side of the motor, and here's our distributor. Now the thing about the distributor, if you look down here at the bottom of the distributor, it has a male end, and this is actually just a stock oil pump drive shaft. We've actually got one in the engine, the one we put in there. But I wanted to show you this because this is going to be sticking up from the pump. This attaches to the pump down here, and this is what's going to be sticking up. There's going to be a female end here. And if you look at the bottom of the distributor, you've got an end that will fit right in there. So that fits right in that gear. And that is what, when this distributor meshes with the cam gear, that's what drives the oil pump down here. Okay, so what we need to do is we need to get this into the cam gear, but sometimes when you put this down in the cam gear, this thing doesn't mesh right away. Okay, so you can actually get into the cam gear here itself, but have this in here like this, and it doesn't actually fall down in there. So the distributor may not fall down in like that, even though you have this gear meshed. Well, there's a real simple way to do that. So we have our engine on top dead center. We know that. So all you need to do, now the distributor basically goes in this orientation here. My vacuum advance is going to point toward the passenger side over here. It's going to point right to about the number 6 cylinder here. My rotor on my distributor, since I have this at number 1, what I need to do is I need number 1, it's real easy to remember, points toward the number 1 cylinder. This is a good way to set it up. So I'm just going to take, and I'm going to rotate, I'm going to drop this in here. I'm not going to go all the way in with it, but I'm going to drop it in. I got my vacuum advance pointing over here, basically toward number 6, this way. And then I'm going to put my rotor on my distributor, and I'm basically going to kind of point it up toward the number 1 cylinder. Okay, so then I'm going to go right in, and I'm going to mesh with my gear. Now, the chances that you are going to get this lined up correctly in that oil pump drive down inside this thing here is not very good. But I just want to go ahead and locate my rotor so I'm close, because my number one on my cap is going to be right here in this area. And so, and of course I have timing adjustment. Right now this distributor is meshed with the cam gear. It's meshed with the cam gear. So this, if I were to turn the motor now, turn the engine now, the rotor is going to turn with the engine. So in other words, I've got this set really close to where I want to be as far as where my number one's going to be on my cap. And so I have enough adjustment that I can set my timing here once I get the engine running. I can go ahead and rotate the engine now, and this rotor is going to stay timed with the cam. But what that will accomplish is if I rotate the engine by hand, it's going to rotate the shaft around so that it falls into the oil pump drive, and you can see a gap here. And what will happen as I rotate the engine, the rotor will move with the gear, and once I get around to where I mesh with the female end on the oil pump drive gear, it'll drop right in. So some people will pull the distributor out and look at the clocking on the distributor and take a long screwdriver and try to move that oil pump and try to get this to drop down in. You don't need to do all that. That's a complete waste of time and effort. That's really not necessary. All I need to do now, since my rotor is where it needs to be and I'm already meshed with my cam gear, what I'm going to do is I'm going to go up and I'm going to slowly rotate the engine clockwise, and you'll see the rotor moving because it's meshed with the cam. And I'm just going to rotate that until I line up with the oil pump drive, and you'll see this thing drop right down where it needs to be. So let me grab my tool here, and I'm just going to rotate this engine clockwise, and I want you to watch that. Now you'll notice the rotor is turning because it is, of course, meshed with the cam gear. So if I rotate this around, eventually, I'm not going to lose my timing. Eventually, and you might want to grab onto this and you kind of push on it a little bit. But if I just rotate this around, eventually I'm going to find that gear. Those gears are going to mess up, and this thing will just drop right there. It goes. It just dropped right down in. Now I'm still timed because my rotor moved with my engine. And if I go back to number one now, my rotor is going to be over here where it needs to be. And that's all there is to it. That's the initial, that'll get you close. So you have timing right here in this area, and you can adjust that timing according to whatever it needs to be once the engine is running. But the distributor is now in, and it's close enough that if I put my wires on, I start here with my cap and I go through my firing order, 1-8-4-3-6-5-7-2. When I go to fire the engine up, this thing should light right up. It should fire up immediately, and that's all there is to putting a distributor in. It's not. This is something that gets overcomplicated a lot, but it doesn't really need to be. So I hope you guys have enjoyed this. It was a lot of fun doing this build. This thing should run really good, and that's pretty much it. There's a few other accessories and things that need to be installed onto this motor, but most of that stuff's pretty straightforward and you can figure that out. My next build is going to be a big block Chrysler. I'm pretty excited about this one. It's a 440 that we're stroking to over 500 cubic inches. I've been wanting to do a Chrysler big block for a while now, and so this is going to be really cool. So if you're a big block Chrysler fan, 440 to 513 cubic inches, I believe, that one is coming up. We're going to start production on that one really quick. I really hope you guys enjoyed this. Be sure to subscribe below, My Vintage Iron 7512. If you have any questions, comments, concerns, complaints, anything of that nature, go ahead and voice them below. I'll try to get to you as soon as I can. I'm overwhelmed, honestly, with all the emails and messages, so I do appreciate all of the support that I'm getting, and I hope some of this helped you guys. I hope you use these videos and do your own builds and make lots of horsepower. So until next time, thanks for watching, and we'll see you then.